So here we have an example of an attempted rendezvous that's going to fail. So we are going to lock our trajectory towards the target and burn until we start to see our distance to target start to come down. At this point, we've dramatically changed our orbit. And so if we fast forward, we'll see that as we move closer to the target, we also move to a higher altitude. When we get to about the same position but a much higher altitude as the target, I'll make another burn to zero out our relative velocity. And then as we can see, at the end of that maneuver, we're still quite a ways away from our target. In this second example, rather than burning directly towards our target, I'm going to create a maneuver node that will make a optimal burn to intersect the orbit of our target after only a short period of time. So some component of our burn is going to be directly prograde, or essentially towards our target in this case, but additionally a large component of our burn is going to be downwards towards the planet, so that while we are changing our orbit significantly, it's going to intersect with our target's orbit much sooner. So now we can see we're going to have a pretty close encounter within a few kilometers, just a short period of time ahead in our orbit. An alternative approach here would be to, instead of burning towards our target at all, to burn retrograde away from our target, slowing ourselves down, decreasing the semi-major axis. And so even though we slow ourselves down in terms of our velocity, we actually decrease the total period of our orbit. So we'll actually end up catching up to the position of our target over a full cycle of our orbit. But here in this case, we've just burned towards the target, a little bit downwards, and now I'm just going to manually zero out that relative velocity around the time that we made our closest approach to our target. Now that I'm within a few kilometers, it's much easier to manually navigate in for a close rendezvous and docking.